the moon is slowing down Earth's rotation. And Earth already slowed down the moon's rotation, so it's tidally locked to us.
We'll one day be tidally locked.
We'll be double tidally locked. And when that happens, then the tides will line up because we'll not be pushing it ahead of the moon.
Here, we're talking about how tides don't just make the oceans rise and fall, they move time and energy around the Earth-Moon system. As Earth spins, it drags ocean bulges slightly ahead of the moon's position. That offset is a torque, like a hand on a flywheel, pulling the moon forward in its orbit and slowing Earth's rotation. You can measure the trade. Laser beams bounced off mirrors left on the moon show it's drifting away at about 3.8 centimeters per year. The energy Earth loses from its spin doesn't just vanish. Most of it becomes heat dissipated in the oceans and seafloor on the order of a few trillion watts, quietly warming the planet at the margins and stirring currents. But here's the part that rarely makes headlines. This exchange rewrites the length of our day. Fossil corals and tidal rhythmites, sedimentary rocks that record daily ocean cycles, tell us that hundreds of millions of years ago, Earth spun faster. In the Devonian period, there were roughly 400 days in a year, which means days lasted about 22 hours. Civilization still treats the day as a fixed unit. We anchor calendars, clocks, and economies to it. Nature's not obligated to honor that choice. So, our official timekeeping occasionally adds leap seconds to stay aligned with a planet that refuses to be perfectly punctual. If you follow the logic forward, there's a destination. As Earth's rotation slows and the moon drifts outward, a balance point approaches where Earth's day will match the moon's orbital period. At that point, the tidal bulge will point directly at the moon, the torque vanishes, and the exchange of angular momentum stops. If nothing else interfered, models suggest this mutual lock would leave both bodies showing the same faces to each other, with a day and a month on the order of several dozen current days. About 47 is a common estimate. The moon would hang over the same landscape in Earth's sky, and the tides would settle into a steady, weaker beat. And here's the twist. We will almost certainly never get there. The timescale to reach this state is tens of billions of years, while the sun will transform into a red giant in about 5. Long before that, solar brightening will evaporate our oceans, changing tidal dissipation dramatically, if not erasing it, well, within the next 1 to 2 billion years. The very mechanism that slows Earth today depends on oceans sloshing over continental shelves. Change the oceans, and you change the clock. In that sense, the path to cosmic equilibrium is blocked by a larger, hotter story unfolding at the center of our system. This isn't a quirk of Earth and the moon. Tides are universal negotiators. Mercury, for example, is not synchronized 1-to-1 with the sun, but caught in a 3.2 spin-orbit resonance, 3 rotations for every 2 orbits, because its eccentric path and solar tides found that arrangement stable. Many exoplanets hugging their stars are almost certainly locked, so that one hemisphere bakes under perpetual daylight while the other faces endless night. For a long time, that sounded like a death sentence for habitability, but climate models show that with enough atmosphere, winds and circulation can move heat around, softening extremes and creating twilight bands where liquid water might persist. Tides shape not just the rhythms of seas, but the boundary conditions of life. Look to the outer solar system and the stakes become geological. Io's roaring volcanoes are powered by tidal flexing as Jupiter needs the moon's interior each orbit. Europa and Enceladus may hide global oceans warmed by the same relentless squeeze and release. Tidal forces are not gentle. They are mechanical engines that turn orbital energy into heat, suppress or trigger magnetic fields, and modulate the chemistry of worlds. If you want to know whether a place is alive, or could be, you ask not just how much light it receives, but how tides move energy through its body. Even our moon, seemingly serene, reveals the complexity. It is already locked to Earth, so we see the same hemisphere, but it wobbles slightly, libration, letting us peek at about 59% of its surface over time. Those small motions carry clues to its interior structure. Earth's own response to tides depends on how squishy or stiff it is, quantified by something called the love number, and how efficiently it dissipates energy, the tidal Q. These are not esoteric parameters. They govern how quickly days lengthen and how far the moon recedes. Shift continents, open or close seaways, change sea level, and you alter Q. The shape of the planet writes itself into the flow of time. So, what does this mean for us, here and now? It means our units are provisional agreements with a changing cosmos. We build civilizations on approximations that serve us well. Seconds, days, months. But underneath, the gears are grinding, however slowly. We already slip leap seconds into coordinated universal time to keep civil time near the solar day, and the world's timekeepers have agreed to phase them out by 2035 because they disrupt global networks, with a replacement scheme still being designed. That's not just bureaucracy. It's a reminder that precision lives at the mercy of a restless planet. The larger lesson is that gravity is not only a force that holds things together, it's a manager of budgets, of energy and angular momentum, balancing books across eons. It edits the pace at which worlds turn and orbits widen. The moon's retreat and Earth's slowing spin are not cosmic accidents. They are the measurable consequences of that bookkeeping. And because the ledger includes oceans, continents, atmospheres, and interiors, every world tells a different story. Earth's day, moon's month, a distant exoplanet's permanent dawn, each is a solution to the same equation. If you look up tonight and see the moon's familiar face, consider that it is more than a companion. It is an active partner in setting the tempo of our planet, a partnership that has sculpted coastlines, regulated climates, maybe even paced the evolution of life. The takeaway is simple. Time, as we live it, is not a backdrop. It is an outcome. Understand the exchanges that create it, and you see our world, and many others, more clearly. Like if this was interesting, and hit the subscribe for more.